This is our world. A warm, comfortable, familiar place. But walk away from the fire and look up. Our thoughts soon leave home. Are we just insignificant specks? Is the universe welcoming or hostile? We could stand here forever, wondering. Or we could turn our back on this beach, leave home, to see the universe, from here to its edge, to discover its wonders, confront its horrors. Beautiful new worlds, malevolent dark forces. The beginning of time. The end of the world. Would we have the courage to see it through? Or would we run for home? There's only one way to find out. The edge of space. Only 100 kilometers up. Just an hour's drive from home. Down there, life continues. The traffic keeps moving. Stocks go on trading, and Star Trek is still showing.
Looks favorable enough at this point that the Rays should go. The Blue Jays will be without starter Jim Clancy for a couple of weeks. The sporting
Order! The honourable gentleman resume his seat. Mr. Hatton.
But we have to leave all this behind. To dip our toe into the vast dark ocean beyond. Into the shallows. Not too far from home. Onto the moon. Dozens of astronauts have come this way before us. 12 of them have walked on the moon itself. Just over 400,000 kilometers from home. 3 days in a spacecraft. So close, it's as if we've barely left home. Familiar, safe, within sight of Earth. It looks like a deserted battlefield, bombarded by millions of meteoroids and asteroids. But it's quieter now. It's obvious there have been no major collisions for millions of years. This brings back memories. The Apollo 11 lunar module. Neil Armstrong's first footprints. Looks like they were made yesterday. There's no air to change them. They should survive for millions of years. Maybe longer than us. Our time is limited. We need to take our own giant leap. Further than any human has ever traveled. Out of the darkness, a friendly face. The goddess of love. Venus. The morning star. The evening star. Sometimes she welcomes the new day in the east, Others, she says goodnight in the west. The planet's spectacular yellow clouds reflect the sunlight. That's why this is the solar system's brightest planet. A sister to our planet. She's about the same size and gravity as Earth. We should be safe here. But the Venus Express space probe is telling us these dazzling clouds are made of deadly sulfuric acid, that the planet's atmosphere is choked with carbon dioxide. It's ringing alarm bells. Venus is one angry goddess. The air is noxious, the pressure unbearable, and it's hot, approaching 500 degrees Celsius. Stay too long and we'd be corroded, suffocated, crushed, and baked. Nothing can survive here. Like this. It's a Soviet Venera robotic probe. Its heavy armor's been wrecked by the extreme atmosphere. So lovely from Earth, up close, this goddess is hideous. She's the sister from hell, pockmarked by thousands of volcanoes. All that carbon dioxide in its atmosphere is trapping the sun's heat. This is global warming gone wild. Before it took hold, maybe Venus was calm, more like her sister planet Earth. If that's true, this could be our planet's future. Beginning to think we shouldn't be out here, that we should turn back. But there's something hypnotic about the sun. Like Medusa, too terrible to look at, too powerful to resist, luring us onwards. On, like a moth to a flame. Dwarfed by, scorched by the sun, it's Mercury. Get too close to the sun, this is what happens. Temperatures swing wildly here. At night, it's minus 170 degrees. Come midday, it's 400 plus. Burnt, frozen, and look at those scars. A sign that Mercury had a violent past. The Messenger space probe. It's telling us something strange. For its size, this little planet has a powerful gravitational pull. It must be heavier than it looks. It's like a huge ball of iron, covered with a thin veneer of rock, the core of what was once a much larger planet. Maybe a stray planet slammed into Mercury, blasting away its outer layers in a deadly game of cosmic pinball. Whole planets on the loose, destroying anything in their path, even entire planets. And we're in the middle of it. Vulnerable, exposed, small. Everything is telling us to turn back. But who could defy this? The sun, in all its mesmerizing splendor. Our light, our lives. Everything we do is controlled by the sun. Depends on it. And more than that, it's the Greek god Helios driving his chariot across the sky. The Egyptian god Ra, reborn every day. The summer solstice sun rising at Stonehenge. For millions of years, this was as close as it got to staring into the face of God. 150 million kilometers from home, a 20-year journey by plane. Switch it off, and it's so far away, we wouldn't know about it for a whole 8 minutes. It's so big, you could fit 1 million Earths inside it. So heavy, its gravity controls the entire solar system. But who needs numbers? We've got the real thing. We see it every day, a familiar face in our sky. Up close, it's unrecognizable. A turbulent sea of incandescent gas. The thermometer rises to over 5,000 degrees. Down in the core, it's got to be tens of millions of degrees. Hot enough to trigger a nuclear reaction, turning millions of tons of matter into energy every second. More than all the energy ever made by mankind. Back home, we see this energy as light, feel it as heat. But up close, there's nothing comforting about the sun. It's so full of electrical and magnetic activity, it's bursting out in these huge incandescent gas loops called prominences. Each one releasing more energy than 10 million volcanoes. You could get the Earth through one of these loops and still have tens of thousands of kilometers to spare. And where they burst through, it's exposing the cooler layers below, making sunspots. They're a fraction cooler than their surroundings. That's why they look black, but they're still hotter than anything on Earth. And they're massive, too. Some of these are at least 50,000 kilometers across. A solar flare. A superheated stream of electrified gas blasting deadly radiation out into space. But one day, all this will stop. The sun's fuel will be spent. When it dies, that'll be it for the Earth as well. This God creates life and destroys it, demands we keep our distance. This comet has strayed too close. It's being boiled away by the sun's heat, creating a tail that stretches for millions of kilometers. It's freezing in here. There's no doubt where this comet's come from. The icy wastes of deep space. But look at all this steam, the geysers and dust. It's the sun again, melting the comet's frozen heart. A kind of vast, dirty snowball, covered in grimy tar. Tiny grains of what looks like organic material, preserved on ice since, well, who knows when. Maybe even the beginning of the solar system. Say a comet like this crashed into the young Earth billions of years ago. Maybe it delivered organic material and water, the raw ingredients of life. It may have even sown the seeds of life on Earth that evolved into you and me. But say it crashed into the Earth now. Think of the dinosaurs. wiped out by a comet or asteroid strike. It's only a question of time. Eventually, one day, unless we can find a way to protect ourselves, we'll go the way of the dinosaurs. The Earth is safe. For now. But if life on Earth was obliterated, we'd be stuck out here, homeless, adrift in a hostile universe. We'd need to find another home. Among the millions, billions of planets, there must be one that's not too hot, not too cold, with air, sunlight, water, where, like Goldilocks, we could comfortably live. The red planet. Unmistakably, Mars. For centuries, we've looked to Mars for company, for signs of life. Somewhere down there could be extraterrestrial life. But are we ready to find it? Ready to rewrite the history books, to tear up the science books, to turn our world upside down? What happens next could change everything. More than any other planet, Mars captures our imagination. Think of sci-fi films, comics. What follows? Martians. It's all just fiction, right? But what if there really is something here? If there is, it's living on a dead planet. The processes that make Earth habitable shut down hundreds of millions of years ago here. Red and dead. Mars is a giant fossil. Something's alive. A dust devil. A big one. Bigger than the biggest tornadoes back on Earth. There's wind here. And where there's wind, there's air. Air that could sustain extraterrestrial life. But it's too thin for us to breathe. Full of choking carbon dioxide. There's nothing to protect Mars from the sun's ultraviolet rays. And it's cold. As low as -80 degrees. Freezing water in the ground, at the poles, and even in the atmosphere. As snow. It's hard to believe anything could live here. But on Earth, there are creatures that survive in extreme cold, heat, and even in the deepest ocean trenches. It's as though life is a virus. It adapts, spreads. Maybe we're carrying the virus of life across the universe right now. Even in the most extreme conditions, life usually finds a way. But on a dead planet, with no geological activity to replenish the minerals and nutrients in its soil, no heat to melt its frozen water, and all this dust, it's hard to see where we're going. But we can't miss this. Olympus Mons. A vast, ancient volcano. 3 times higher than Everest. So wide, it would stretch almost all the way across Spain. Since its discovery in the 1970s, it's been declared extinct. It looks like there's something happening on its slopes. It's as though lava has been flowing. But any lava flows should be long dead, obliterated by meteorite impacts. Unless this monster isn't dead after all. If it's not, there could be molten magma beneath the crust right now. This changes everything. Volcanic activity could be melting frozen water in the soil, recycling minerals and nutrients, creating conditions for life to exist. This makes the Grand Canyon look like a crack in the pavement. It goes on and on. So far, it would stretch all the way across North America. But look, signs of activity, erosion, and what looks like dried up riverbeds on the canyon floor. Maybe volcanic activity melted ice in the soil, sending water flowing through this vast canyon. Activity that we now know could still be melting ice, creating water. And where there's water, there could be life. If we can find running water, there's a chance we could find living creatures. Trundling across this desolate landscape, the NASA rover Opportunity. It's finding evidence that these barren plains were once ancient lakes or oceans that could have harbored life. Look at these gullies. When probes orbiting Mars pass over them, they keep spotting new ones. More proof that Mars is alive and kicking. That there may be water flowing beneath the surface, creating these gullies. Water which could be sustaining Martian life. Now all we have to do is find it. Unless we've already found it. Not on Mars, but on Earth. There's one theory that has life starting here before moving to Earth. The idea is that an asteroid impact blasted fragments of Mars, complete with tiny microbes, out into space and onto the young Earth, where they sowed the seeds of life itself. No wonder we find Mars fascinating. It could be our ancestral home. If it's true, it means we're all Martians. The Mars we thought we knew is gone, replaced by this new, active, changing planet. And if we don't know Mars, possibly the solar system's most studied planet, what else don't we know? There must be other secrets out there, waiting to be discovered. This is getting scary. It's like being inside a giant computer game. But these are all too real. Asteroids, some of them hundreds of kilometers wide. This one must be about 30 kilometers long. And look, perched on it, a space probe. Can't have been easy parking on an asteroid traveling at 80,000 kilometers an hour. It's a lot of effort to investigate some rubble. Rubble that regularly collides, breaking up and raining down on Earth as meteorites. Magical tokens, supernatural omens, and more than that. Turns out it was rubble like this that came together to make the planets, including our own. So by dating the meteorites we find on Earth, we know the planets were born 4.5 billion years ago. These are the birth certificates of our solar system, of our planet. But for some reason, these rocks didn't form into a planet. Something must have stopped them. Something powerful. Jupiter. What a monster. At least 1,000 times bigger than Earth. So vast, you could fit all the other planets inside it. Something this big is going to have a major effect on its neighbors. Its gravity is stopping the asteroids from forming a planet. And just look at it. It's stunning. But up close, maybe things aren't quite what they seem. This huge planet is almost all gas. Land here, and we'd sink through its layers, maybe never hitting a solid surface. And Jupiter's good looks, the product of extreme violence. It's spinning at a huge rate, whipping up winds to hundreds of kilometers an hour, contorting the clouds into stripes, eddies, whirlpools. And this, the legendary Great Red Spot. The biggest, most violent storm in the solar system. At least 3 times the size of Earth. It's been raging for over 300 years. All those churning clouds have sparked an electrical storm. Just one bolt is 10,000 times more intense than any at home. It seems the best place, the safest place to see Jupiter is from a distance. That's just beautiful, dancing round the poles like the aurora back home. But the Geiger counter is going wild. It seems even these are deadly, generated by lethal radiation pulled from space by Jupiter's powerful magnetic field. We're beginning to realize out here, nothing is what it seems. The universe is full of contradictions, deceptions, traps. Right now, we need a safe haven. Somewhere to find our feet, catch our breath. Maybe this, the multicolored moon Io, is it? Those pretty colors, a molten rock, sulfur, volcanoes, spewing burning hot ash and sulfur hundreds of kilometers into the air. This is no safe haven. This is the most volatile place we've seen since the sun. Our magical journey to the edge of the universe is turning into a desperate flight. We've got to keep believing, hoping that amidst the dangers, there are wonders waiting to be discovered. $650 million kilometers from home. What a weird-looking place. And yet it looks strangely familiar. A bit like the Arctic with all that ice, all those ridges and cracks. This is Europa, and maybe, like the Arctic, this ice is floating on water, liquid water. It's an intriguing thought. But we're 800 million kilometers from the sun. Surely Europa is frozen solid. Unless Jupiter's gravity is creating friction deep inside, stopping Europa from freezing solid, allowing life to develop in the waters beneath its frozen crust. We might be meters away from aliens. From a whole ecosystem of microbes, crustaceans, maybe even squid. The only thing between us and the possibility of alien life, this layer of ice. But until we send a spacecraft to drill through the ice, Europa will remain one of the solar system's greatest mysteries. It's captivated our imaginations, haunted our dreams. And here it is, spinning before our eyes. Saturn, the jewel in the solar system's crown. Seeing it makes everything we've experienced worthwhile. There's something magical about Saturn. A giant ball of gas, so light it would float on water. Its spectacular rings would stretch almost from Earth to the Moon, but they're just a few hundred meters deep. That's the Cassini orbiter. It's picking up ghostly radio emissions, probably generated by auroras around Saturn's poles. This is the real music of the spheres. And Cassini is telling us these rings are probably all that's left of a moon shattered by Saturn's gravitational pull. Incomparable beauty from total destruction. Billions of shards of ice, some as small as ice cubes, others the size of houses. They collide, break apart, reassemble. It's like a snapshot of our early solar system, as dust and gas orbited the newly born sun, and gravity worked its magic, pulling the lumps together until from debris like this, our home emerged. We could stay here forever, gazing at Saturn's seductive allure. But we have to drag ourselves away. We've got so much further to go, so much more to learn. Which isn't easy when the largest object in sight is this moon, wrapped in thick clouds. Titan. It seems like there's an atmosphere down here. There's wind, rain, even seasons. And look at these rivers, lakes and oceans. It's the most similar place to Earth we've seen so far. Maybe it was worth tearing ourselves away from Saturn after all. Except that's not water. That's liquid natural gas. There must be hundreds of times more natural gas here than all the Earth's oil and gas reserves. If we could get it home, it could power our cities, fuel our cars for thousands of years. Or maybe, one day, we could use it here to fuel a colony. Assuming there isn't life on Titan already. The Huygens space probe, dropped onto Titan's surface from Cassini, is here to find out. It's telling us there are organic materials in the soil, but it's so cold, minus 180 degrees. There's no way these could come together to form life. Unless Titan warms up. The sun is predicted to get hotter. When it does, maybe life will spring up here, just like it did on Earth billions of years ago. As the Earth gets too hot for us, maybe we'll move to Titan. One day we might call this distant place home. Home. We're at least 1 billion kilometers away now. Beyond this point, we lose visual contact with the Earth. We're standing on a cliff, looking out into the solar system's mysterious outer reaches. If we want to understand the universe, to reach its edge, we have to jump. Unseen from Earth, unknown for most of history, we're in the solar system's outer reaches. It's like diving down into the deep ocean. Those rings. It looks like Uranus has been tilted off its axis, toppled over by a stray planet. It's eerie out here. Already beginning to feel small, lonely. Maybe this is how we'll feel, what we'll find at the edge of the universe. But we've barely left the shore. Shrink the Earth down to the size of a pea. We've traveled less than 2 kilometers. But to reach the edge of the solar system, we've got to travel another 20,000 kilometers. Out of the deep, another strange beast. The god of the sea, Neptune. This giant is swathed in methane gas. And look, a storm the size of Earth, whipped up by savage 1,500-kilometer-an-hour winds. Back home, it's the sun that drives the wind, but Neptune's too far away. Something else must be creating these ferocious winds, but nobody knows what. Our solar system is huge. It's alarming how little we really know about it. Plunging deeper, something to cling to. After all those balls of gas, a solid moon. Triton. Solid, but not stable. Just look at these geysers, cosmic chimneys pumping out strange soot. And this moon is going round Neptune in the opposite direction to the planet's spin. A cosmic battle of wills that this angry moon is always going to lose. Neptune's massive gravity is pulling on Triton, slowing it down, reeling it in. One day, it'll be ripped apart by Neptune. And that's it. No more moons, no more planets to see in our solar system. It's getting colder. We're getting further from the sun, slipping from the grip of its gravitational tentacles. But look at all this. It's not a void. It's teeming with frozen rocks, icy spheres, like Pluto. Until recently, it seemed Pluto was alone. Beyond it, nothing. We were wrong. More frozen worlds. Discoveries so new, nobody can agree what to call them. Plutinos, ice dwarfs, cubanos. Whatever the name, the implications are the same. Our solar system isn't the neat model we thought it was. Over 13 billion kilometers from home, the most distant thing ever seen to orbit the Sun, another small, icy world called Sedna, discovered in 2003. Its orbit takes 10,000 years and sends it 130 billion kilometers from the Sun. Hang on, there's something else out here. 16 billion kilometers from home, the space probe Voyager 1. If it wasn't for this bundle of aluminium and antennae, we'd have no images of the giant planets, no clue about their strange moons. It's traveling 20 times faster than a bullet, sending messages home. And look, on its side, that gold panel, a kind of intergalactic message in a bottle. There's a greeting recorded in different languages. And a map showing how to find our solar system. But if you're in the jungle, is it wise to call out? Anyone, anything could hear our call, find out where we live, and come knocking. Friendly or not. A cloud of cosmic icebergs stretching for what seems like forever. They look like the comet we saw earlier. Maybe it started life out here, until something dislodged it, sending it towards the Sun, just like the comets that may have planted life on Earth billions of years ago. And seeing all this ice, maybe they carried water to Earth too. It's an astonishing thought. The water in the oceans, in your coffee, even in your body, all from this distant celestial ice machine. We're 8 million, that's 8 trillion kilometers from home. But in reality, this is only a baby step. Ahead, trillions of kilometers, billions of stars. This is it. Time to stop looking in and start looking out. To step out into the big, wide universe. Into interstellar space. Interstellar space. Far beyond our solar system. What a view. Billions of stars like our own sun, many with planets, many of those with moons. It's hard to know which way to go. There are infinite possibilities in every direction. Whichever way, we're going to need a serious burst of acceleration. $40 trillion kilometers from home. 150,000-year ride in a space shuttle. And we've only just reached the first solar system after our own. Alpha Centauri. Not one, but 3 stars. They're spinning around each other, locked in a celestial standoff. Each star's gravity attracting the other, their insane orbital speed keeping them apart. Get between them, and we could be flung into the face of one of these stars. Vaporized, trillions of kilometers from home, So far, the kilometers are becoming meaningless. We're going to have to talk in light years. A beam of light takes 1 year to travel 10 trillion kilometers. So 40 trillion kilometers is 4 light years from home. It's crazy. Distances so vast, they're almost beyond comprehension. And exciting. Who knows what strange worlds lie ahead? What we'll discover when, if we reach the edge of the universe. "10 light years from Earth, the star Epsilon Eridani. What spectacular rings of dust and ice, and somewhere in there, planets forming out of the debris, being born before our eyes. Asteroids and comets everywhere. We could almost be looking at our own solar system, billions of years ago, with comets delivering organic molecules, water to these young planets, kick-starting life, just as they may have done on Earth. At the center of all this action, a star smaller than our sun. It's still in its infancy. Any life in this solar system would be primitive at best. There must be more mature, developed solar systems out here. But finding them is like looking for a needle in a cosmic haystack. "20 light years from Earth. Star Gliese 581. It's about the same age as our sun. And orbiting it, this planet. It's just the right distance from its sun. Any closer and water would boil away. Any further and it would freeze. Ideal conditions for life to have evolved. And if comets have struck, delivering water and organic materials, then life, complex beings like us, even civilizations like our own, could be down there, right now. And if there are, even at this distance, they could be tuning into our TV signals, watching shows from 20 years ago.
And here's your host, Joe Kaplan.
But until future generations can find a way of communicating over these vast distances, all we can do is speculate. Us and them, living parallel lives, unaware of each other's existence. Unless life has been and gone. That's the problem with comets. They're creators and destroyers. As the dinosaurs found out the hard way 65 million years ago. This is the needle in the cosmic haystack, the closest we've come to a habitable solar system like our own. But it's a chance encounter. There could be hundreds, millions more solar systems like this out here. Or none at all. this is vast. And look, it's the planet Bellerophon. So close to its own sun, it's a miracle it was discovered at all. Problem is, from Earth, we can't see planets this far out. They're obscured by the brilliance of their neighboring stars. But the planets have a minute gravitational pull on those stars. Measure these tiny movements trillions of kilometers away, and we can prove they exist. That's how we tracked down Bellerophon in the 1990s, opening the floodgates to the discovery of hundreds of other distant planets. 65 light years from Earth. Tune in on this bright star, and you'd pick up TV signals from Hitler's Berlin Olympics. Twin stars. It's Algol, the demon star, feared since ancient times on account of its sinister behavior. From Earth, it appears to blink as one star passes in front of the other. Up close, it's even stranger. One star has expanded into the gravitational pull of the other. It's being sucked towards it. Almost 100 light years from home. Listen. One of the first ever radio broadcasts. Just a faint whisper.
We'd appreciate it if anyone hearing this broadcast would communicate with us. We are very anxious to know how far the broadcast is reaching.
And then silence. From here on out, it's as if Earth never existed. Any aliens living beyond here will have no idea we're there. It feels like a lifetime ago we stood on that beach, looking up at the sky, wondering where and how we fitted in. It's time to appreciate the wonders we're seeing, not just for what they tell us about our own world. It's what they can tell us about the whole universe, its past and its future. Deep inside our galaxy, the Milky Way, a vast celestial library, each star a book with a story to tell. It's all here, waiting for us to lift the cover. The seven sisters, daughters of the ancient Greek god Atlas, transformed into stars to comfort their father as he held the heavens on his shoulders. And this giant, Betelgeuse, the brightest, biggest star we've seen so far. It's got to be at least 600 times wider than our own sun. But this, it's not a star. Not a planet. Not like anything we've ever seen. A ghostly spectre, more than 1,300 light years from Earth. Orion's dark cloud. Dust and gas, so dense it's shrouding us, shutting us off from the universe outside. There, deep inside, a ball of light, pulling the dust and gas towards it, heating up, merging into a ball of burning, hot gas. Like a star, like our sun, in miniature. It's millions of degrees inside it. So hot, it's beginning to trigger nuclear reactions, the kind that keep our sun shining. Making energy, radiation, light. A star is being born. Or rather, stars. Orion's dark cloud is a vast star factory. We're witnessing the birth of the future universe. We've come to expect hostile horrors, but we're discovering one of the universe's greatest creative wonders: star birth. Perhaps we spoke too soon. Jets of gas, exploding outwards at 200,000 kilometers an hour, blasting dust and gas out for millions of kilometers. It's unbelievably violent, but look at the results. It's beyond words. Nebula. Vast glowing clouds of gas hanging in space. With no wind out here, they'll take thousands of years to disperse. They seem to be forming a vast stellar sculpture. It makes you realize nature is more than a scientist, an engineer. It's an artist on the grandest of scales. We've seen some strange sights, but this is a masterpiece. A giant horse's head rearing up in space. Stars are born, grow up, and then what? Do they die? Do they slip quietly into the night, or go out with a bang? Somewhere between here and the edge of the universe lies the answer. Nearly 4,000 light-years further, luminous clouds suspended in space, encircling what was once a star like our own sun. All that's left of it are these brightly colored gases. Elements formed by nuclear fusion deep inside the star, released into space on its death. Green and violet, hydrogen and helium, the raw materials of the universe. Red and blue, nitrogen and oxygen, the building blocks of life on Earth. For us to live, stars like this had to die. The oxygen in our lungs, the nitrogen in our DNA, it was all produced by nuclear fusion in stars that died long before the Earth was even born. We are made of stellar nuclear waste. Our family tree begins here. At its heart, the ghost of a star. It's a white dwarf. White, hot, small, but unbelievably dense. In the star's dying moments, its atoms fused and squeezed together, making it so dense that just a teaspoon of this white dwarf would weigh 1 ton. It's a chilling premonition of our sun's fate. 6 billion years from now, it'll become a white dwarf. Its death will herald the end of life on Earth. It makes you wonder how many other worlds have been and gone. Stories left untold. Celestial books lost forever. But the greatest story of them all is still to be told. We must go back through time to the very first chapter to tell the story of how the universe began. The scattered remains of a dead star. A nebula, the Crab Nebula. We're 6,000 light years from home, deep inside a stellar graveyard. We've learned so much, seen things we'd never have believed possible. Now, sights like this, wonders once beyond imagination, we take in our stride. We're ready. Ready to face whatever lies ahead. Determined to reach the edge of the universe. It looks dead, but maybe this is just the calm after the storm. After a massive explosion. Powerful enough to turn a huge star into a cloud of dust and gas. A supernova. The eye of the storm, a spinning, pulsating star, a pulsar. Gravity must have squeezed the giant star's core down to this. It's just 20 kilometers across, unimaginably dense. One pinhead of this would weigh hundreds, maybe millions of tons. As it shrank, like a figure skater spinning on the spot, arms outstretched, then pulling them in, it began to spin faster. Two beams of light, energy, radiation, spinning 30 times a second, powering the huge cloud of dust and gas. There's so much radiation here, more even than on the sun. That was easily the deadliest thing we've encountered so far. Once, it would have terrified us. But now we realize that without the dangers, there'd be no wonders. Without the nightmares, there'd be no dreams. Getting a strange sensation. A feeling, as though there's something bad out here. A malevolent presence. The one thing we didn't want to encounter. Impossibly black, blotting out the stars behind it. We are staring into the face of extinction. The remains of a giant star. A black hole. Instead of contracting to a white dwarf or a pulsar, it just kept on going. Shrinking until it got so small it's just a few kilometers across. Far denser than a pulsar and impossible to resist. Stray too close, and there's no turning back. Now we know why it's a black hole. Its gravity is so intense, not even light can escape. This asteroid, it's a lump of solid rock. but it's actually stretching, being dragged towards the gaping hole. Inside, there's no matter as we know it. No time, no space. All the rules of physics collapse. The asteroid is gone. Truth is, nobody really knows where. We're looking at the limit of human understanding. There could be millions of black holes creeping around our galaxy. More perhaps than all the stars in the sky. But we wouldn't see them until it was too late. Like this star, spiraling, disappearing down an invisible plug hole. Who's to say we don't live inside a vast black hole? That the whole universe isn't inside one right now, inside another universe. Think about it for too long, and your mind reels. Sometimes it feels like the more we see, the less we know. But we do know our galaxy is more complex and more dangerous than we ever imagined. And we're still in our own galaxy, the Milky Way. The vastness of the universe beyond still lies ahead. The wonders, the dangers, the secrets, they're out there. But first, we've got to find a way out of the Milky Way. "7,000 light years from home, still deep inside our own galaxy. It's as though we're in a forest thick with trees, each so beautiful, so fascinating. It's impossible to look beyond, to see the bigger picture. We have to find a way through, reach the clearing at the galaxy's edge. Only then can we begin to understand where it and we all began. But faced with sights like this, it's hard to leave. A colossal glowing cloud topped by these great towers of dust. The pillars of creation. Like a gateway into the far galaxy. Both pillars studded with tiny protrusions. Embryonic star systems. Each one the size of our solar system. Another monument to nature's astonishing creativity. We have to ignore its captivating beauty, its siren song, tear ourselves away, in order to carry onwards towards the edge of the galaxy. Dazzled by the Milky Way's beauty, we've been blinded to its terrors and strayed into a cosmic minefield. Like an explosion in slow motion, giant clouds of gas are bursting out of this star. A massive star, millions of times brighter than our sun. It's going into meltdown. The fuel that sustains it is running out. The nuclear reactions that power it winding down. We're watching its death throes. Eventually, the core will implode. The result, a new black hole. An even bigger, dangerously unstable star. But this one's about to explode. And when a star this big dies, it's 100 times more violent than a supernova. Somehow we've stumbled into the most violent star death imaginable. A hypernova. The core's collapsed. It's becoming a black hole. And that's the shockwave, surging through the star, ripping its outer layers into space. There's lethal radiation everywhere, enough to have a catastrophic effect on any planet unlucky enough to be nearby. When virtually every species on Earth was wiped out 450 million years ago, the culprit may have been one of these. Deadly hypernovas, frozen comets, scorched planets, white dwarfs, red giants, Earth. Tiny drops in a vast pool of white light. Our home galaxy, the Milky Way. We want to know where we fit in. Here's our answer. Civilizations, past and present. Everyone that's ever lived. The smallest bug, the highest mountain. All of it. Invisible. Not even a tiny speck. Our home is a minor planet of an insignificant star. If it disappeared right now, who or what would even notice? And yet, so far we found nowhere else we would rather live. Nowhere we could live. It's only now, far from home, that we're beginning to truly appreciate it. Look at all these stars. Hundreds of thousands of them. Surely one of these, more than one, must be capable of supporting life. Maybe here, in this swarm of stars, the Great Cluster. Back in the 1970s, astronomers sent a message in this direction, detailing the structure of our DNA and our solar system's location. But it's so far from home, the message won't arrive for at least another 25,000 years. We haven't found alien life yet. But neither have we found any reason to believe it isn't out here, somewhere. There's an equation, devised to estimate the number of other advanced civilizations. Crunch the numbers, and the result is shocking. There could be millions of civilizations, just in our own galaxy. Everything we have seen so far is inside the Milky Way. Now here's our chance to see other galaxies, to glimpse the even bigger picture, and perhaps to answer the ultimate question: where does all this come from? We are now ready to leave our solar system, our galaxy, and enter intergalactic space. Beyond the Milky Way, through the vast expanse between galaxies, against all the odds, we've made it to intergalactic space. Out here, there's no horizon in sight. Even the closest galaxies are millions of light years away. The remains of galaxies ripped apart by the Milky Way's huge gravitational pull. Scattered through, nothing. This is as close as the universe gets to a perfect vacuum. But even this isn't totally empty. There are thin wisps of gas, fine traces of dust, and something else. Dark matter. So mysterious we can't see it, feel it, taste it, touch it, or even measure it. Yet so common, it could make up over 90% of all the matter in the universe. If dark matter does exist, it means there's no such thing as empty space. Even out here, we're surrounded by matter. We only know it exists because of the strange hold it exerts on galaxies, like this one, the Large Magellanic Cloud. More than 6 billion years in today's fastest spacecraft, 160,000 light-years from the Milky Way, at the edge of its gravitational reach. This galaxy should spin off into space, but something is holding it here. Something invisible, powerful, dark matter. Stars, clusters of stars, nebulae. It's a vast astronomical treasure house. But look at this. It's like a string of gleaming pearls. It's a fireball, expanding out from what must have been a massive explosion. A supernova. So bright that when light from the explosion reached the Earth in 1987, it was visible with the naked eye. And so violent, it triggered a string of nuclear reactions, forcing atoms together, creating new elements. Gold, silver, platinum, blasting them out into space. The gold in the ring on your finger was forged in a massive supernova like this, trillions of kilometers away, billions of years ago. Before we left home, the universe seems separate. Something out there, up in the sky. We were wrong. The story of the universe is the story of every one of us. It's comforting to remember as we venture through this abyss. Further and further. Faster and faster. The Andromeda Galaxy, 2.5 million light-years away. It's moving through space at nearly 1 million kilometers an hour. Everything in space is moving apart like shrapnel from an explosion. We're seeing this galaxy as it was when our ape-like ancestors first walked across the African plains. We go further through space, and further back in time. This doesn't look right. A whole galaxy exploding. The only thing large enough to cause an explosion on this scale has to be another galaxy. It looks like the end of the world, but we've seen enough to know things are never that simple. This galaxy won't die. It'll be reborn. A new shape, perhaps even new stars. As dust and gas collide, creating friction, shockwaves, triggering the birth of stars. There's order in this chaos, a pattern behind the infinite variety, an endless cycle of birth and death, creation and destruction. It's a pattern woven through the vast fabric of space that binds each of these galaxies. There are billions of galaxies in the universe, each with billions, even trillions of stars. Possibly more stars than there are grains of sand on all the beaches on Earth. And all of these are just the stars that exist now. What about the stars that have been and gone? All the stars being born, yet to be born. We're finally beginning to see the big picture, and it's grander than we ever imagined. This galaxy, the huge pinwheel galaxy, is so far from Earth that if we send a message home now, it'll take 27 million years to get there. Who knows whether our species, our planet, will still be around to receive it? Most likely not. We travel on, back through time. Past the point where the dinosaurs were wiped out. Past the moment where the first creatures clambered onto land. "2 billion light years from home. Closing in on the edge of the universe, going back to the beginning of time. This isn't a galaxy. It's brighter than hundreds of galaxies put together. A blinding beam of energy bursting out for trillions of kilometers. Something this big, this bright, must be incredibly powerful. Experience tells us, out here, power equals danger. It looks like a quasar, the deadliest thing in the universe. If it is, then our journey could be over, just as the end is almost in sight. The deadliest, most powerful thing in the universe. A quasar. A swirling cauldron of super-hot gas, brighter than hundreds of galaxies. The source of this awesome power lies deep inside the heart of the beast. A heart of darkness. A supermassive black hole, as heavy as 1 billion suns. It's ripping apart whole stars, sucking their gases into the quasar, devouring them, until they're nothing, lost forever from the visible universe. We've seen the worst the universe can throw at us, the most powerful and destructive forces the universe produces. Now it's on to the very edge of the universe. It's almost within reach. We'll need to go further, go faster if we're to cross the final reaches of the known universe. "8 billion light years from home. More galaxies. But these look different. Ragged, small, close together. We're so far back in time, we're seeing these galaxies as they were before the Earth was even born. They're still young, still growing. We're getting closer to where and how it all began. 12 billion years ago. Look at the galaxies now. They're more like primitive plankton floating in a vast, dark ocean. It's magical. Clouds of dust and gas, dancing, forming a shape, merging to make embryonic galaxies. This is how our own galaxy was born. They're disappearing. We've gone back before the stars were born. Into a cosmic dark age. And before that, light. The afterglow from a massive explosion. The explosion which created the known universe. We're almost there. This is it. We've made it. The edge of the universe. 130 billion trillion kilometers from home. 13.5 billion years ago. The very instant of the Big Bang. The most violent, most creative moment in history. Everything that's ever happened follows from this moment. Every religion, every culture has pondered it. But we still don't know what sparked this act of creation, or why. This is where our journey ends, and the universe begins. An infinitely hot, small, dense point erupts. Creating space, time, matter, our universe itself. First, it's the size of a subatomic particle. The tiniest fraction of a second later, it's big enough to hold in the palm of your hand. Moments later, it's the size of the Earth. Today, the light from the Big Bang is still spreading out as a hiss of radio static. Your TV aerial picks it up. You can see it as static on an untuned TV. We go on. Forwards through time, riding the blast wave. All the things we've seen on our journey are sparks flying out from the Big Bang. Galaxies, stars, planets, all just debris. Back through our galaxy. Our solar system. Until we reach another cooling cinder, swirling in the afterglow of the Big Bang. The Earth. We had to go back to the past to see our future. Three billion years from now, the vast Andromeda galaxy smashes into our own. A new galaxy is born. The sun and planets survive, but they've been thrown into a huge looping orbit around the new galaxy. The sun is becoming a red giant, swallowing up Mercury and Venus, scorching our planet's surface, destroying all life on Earth. The sun dies, shrinking to a white dwarf. Neighboring stars are dying too, being replaced by white dwarfs, pulsars, black holes. The lights are going down on the galaxy. Since the Big Bang, the universe has been fading, dying, not with a bang, but with a long, drawn-out whimper. But there could be a way out, an escape route from our dying universe. It might be possible for our distant descendants to find a shortcut through space and time. A wormhole. If there are other universes, it could take our descendants from our doomed universe into a parallel one, where they could find another Earth, still in the prime of life. If they're lucky enough, they will live on in a new universe. A new home.